So today I am going to explain the fourth problem of Leetcode Weekly contest 292. This is quite the easiest contest of last I think 2 or 3 months. The fourth problem feels like also Leetcode easy medium type of problem. The third problem I find more interesting than the fourth one. So what is the problem? So we are given a matrix of parentheses and we have to find if there exists a path from the starting cell to the end cell where the parentheses like the parentheses formed by the by moving into the path, traveling into the path is balanced. I hope you all know what is balanced parenthesis thing. The balanced parenthesis string is the string which has a equal number of the open parenthesis and close parenthesis, and at any point the number of open parenthesis is greater than equal to the number of close parenthesis. So for that, the first case you can check out is that the parenthesis string formed by moving into this path is like first three open parentheses and last three close parentheses. So it is a balanced parenthesis string. So for solving this problem, you have to also check the constants. The constants are quite low, 100. M or n is 100. So n cube solution will also pass. N to the power 4 can also pass for C++. So let's check. For this kind of problem, what is our observation? What we can do is that for any given parenthesis string, uh, this type of problem, we do require a variable which is balanced. The balance at any point will give us the difference between the number of open parentheses and number of closed parentheses. So let us form the balance array for this parenthesis string. So it will be 1 because number of open parentheses is 1. So for this it will be 2. This is also open 3. So now this is closed. So 2, 1, 0, 1, 0, minus 1. So if our parenthesis string is valid, then the balance at any moment of time is greater than equal to 0, and at the end the balance should be equals to 0. Okay, so this is the normal observation. Like for this type of problem, you should always think about balance. uh, what we can do is with the balance, because balance we can give us like an array of integers, and we are like comfortable while like uh, working with the array of integers. So just try once to build the balance array and do some operations. So here n and m is greater than less than equals to 100, so we can do, I have already told that in order of n cube solution will also pass. So we can take that if we do some kind of recursion or DFS kind of thing, DFS in grid, so the two variables will be I comma j and our balance. So let's build a matrix of n cross m. So n cross m. So what is the length of the path from the first cell to the last cell? The length of the path from the first cell to the last cell will be always n plus m, wherever path you go, because no diagonal is allowed. So n plus m could be the number of the length of the path. So what would be the maximum value of the balance? The maximum value of the balance would be n plus n, and at any moment of time our balance could not be negative. So balance, the limit of balance would be 0 to n plus n. Okay, so this is 0 to n plus m. So we can do one kind of DT. So first index will be I, which is row number obviously, and second index will be j, which is the column number, and what is third index will be balance. And the limit of first is 100, second is also 100, and the third is n plus m, which is 200. Okay, so this is quite trivial. So when we move to one cell to another cell to adjacent cell, we will increment the value of balance based on or decrement based on the what is the character of that this cell. Okay, I hope you will understand my code now. I will show you my code. There is nothing special about the problem. This is quite trivial problem. So this is first I am checking out the value of the length, number of rows, which is n, and m is the number of columns. So now I am storing it into two global variables, n, the number of rows and number of columns, and s will store as the matrix. So I am using global variables the such that I don't have to pass it into the recursion function. So first I am this thing is also common to you. I am like, you can also use in main set, but I have thought is that if there are more number of test cases, this would give us clearly. So I have not used the main set function. So now recursion, our current value is equals to balance, and based on the current cell value, I am incrementing the value of balance or decrementing the value of balance. Okay, and if our current index is the last index, we are returning if our current balance value is equals to 0 or not. So now if current is less than 0, we are returning 0, because at any moment of time the value of balance is greater than equals to 0. So now we are moving to the any of the adjacent cells and doing this dpij val or equals to I think you will all understand that what I am doing. uh, at the end I am returning dpij balance from here. Okay. I hope this is quite easy contest for all of you, and I don't think you will not find it hard to solve this problem or the third problem. I will also explain the third problem too. If you understood my solution, please like the video and subscribe to my channel. Thank you.